Hello guys, and since we're on a Christmas light kick, I figured I would make a little video here of some older, what I call tungsten type Christmas lights. These are the glass bulbs with the little filaments in them, the older style, pre-LED type. And this is an alternating set. As you can see, they're alternating between the white and blue. Now, a quarter, or let's say a third of this string is dead because some bulbs are missing and some sockets have been crushed. Therefore, this string will be recycled into the wire and bulb bins respectively. So I thought, before I went to just cutting and tearing this apart and pulling all the bulbs out, etc., that I would look into the control box. Now this is the controller here. It goes from steady to slow, and you can see I'm turning it, and when it says slow, it is very, very slow to fade between the twos, from fading off to full brightness, etc. Whereas fast is a little faster, and as you turn it towards steady, it locks in the steady. It's kind of hard to get a extremely fast going. This knob here is kind of stiff to move. I don't know if that's because of waterproofing or if that's something to do with it's just old or whatever. And these, I don't know the exact make of these, but the model is a WL305-2. 120 volts, 60 hertz, 0.6 amps for indoor and outdoor use. And the screws are potted with the silicon. I've started trying to cut these, and I thought, well, maybe I should record opening this. So I have my screwdriver here, and we'll take, the screws are in there quite tightly, and with that silicon, it makes it a little more difficult to grip. Oh, that's why. They're not actual Phillips head screws. They are these triangular heads. Do I even have? I don't know if I even have that type of deal. Huh. Well, that's interesting. Well, we'll keep using what works, what I know is working, and I'm just cutting out as much of the silicon as I can. If it gets too hard to get the screws out, I might have to use very unreasonable force. Hopefully not. Hopefully I could just keep doing what I'm doing and these things bite the Phillips head, and I'm not putting them back in, and I should probably unplug the lights before I get in too deep with these, because, you know, electricity, metal, screwdriver, exposing live connections, that type of thing. So it's trying to give way. I'll never use those screws, so they'll go straight into the bin, trash can bin, or the recycling bin. If those of you who are green, oh, throwing metal in the trash, why don't you recycle it? Really? Okay. Oh, and the end. Okay. Wow, that one there is in there. It does not want to come out. Now this is a kind of a neat box. It is weatherproofed, I see. It might keep the actual box, but I'm not keeping these horrendous triangle-headed screws. I'll take this there. Okay. And it does have a proper gasket on it here. This orange gasket. And what we got? Here's the power that comes in. The power comes in here. It's got this lead here. This pair goes to the other end of the string with the plug where you can chain these. And this one's coming in, and basically what we have is we got it coming in. It's going through a, looks like a full bridge rectification. It's got our capacitor here. That That's not sure what that is. That's a resistor. Okay. It's got a, of course, the capacitor, and then we've got this potentiometer here, which is a little easier to move here. So that alludes that this is actually sealed. It's clipped in, but it's very tight to where water may or may not get into that. And what's happening is, not sure what. Here's our microprocessor. This is what does the driving to switch these channels on and off between each other, faster, slower, on. And it's switching the pair of transistors to turn these on and off. We have, you know, this is a zener diode that's limiting the voltage into the microprocessor, is what that looks like. But yeah, that's it. I mean, this isn't really nothing new. Oh, that's really neat. That comes apart like that, and then it just kind of goes back together like that. Or did I break it? I think I may have broken this. Oh, whatever. Put it with the box. So I wonder what the voltage would be coming out of that that end. What kind of voltage is it supplying? I'm going to put it on DC volts. I'll put it at 200 because I don't know. Yes, messing with live voltages and things here. Okay, that's all the way slow, of course. I would go the wrong direction with it. So we know we got 120 volts AC coming in, and we'll show that. Got the meter here. It's on AC 200, and we know we got 120, or in my case 107. It's a little low. I think that's because my central heat is running. It drags it all down for some reason. And then we got DC voltage should be coming out of this side. What volts? That is... Shit. Okay. Well, something just went bang. The transistor went bang, because I think I may have shorted something. Shit. Well, it is going to the garbage, so... Anyway, I think it was about 90 volts DC coming out of this. So that transistor went pop. Why did it go pop? The transistor number is X226. Not really sure. Oh well, I think it was about 90 volts DC coming out of that. And I think I may have bridged something accidentally across, probably touched those two and caused it to go bang. Well, the excitement on the channel so far is yeah. So that's that transistor, and I think it needs that. Look, it's got provisions for 2 more channels here. I wonder if I were to add, so one of these is common. Here's our common rail here. This one is the common, and I think I may have just shorted between those, accidentally, not realizing it, and made it go bang. Yes, a piece of that did hit me in the arm. Here's our common rail. It's coming off of a diode, one of the rectification diodes here, one of the bridge. We have our smoothing capacitor, and that looks like that high value resistor. It may be this one, or is it that one? Probably the 1 meg here would be our discharge. resistor for the capacitor, so we don't get a zing when we touch the leads. You know, that's only a 16-volt capacitor, though. That's interesting. Microcontroller. So yeah, that's basically, I'm not going to draw a diagram of this. This is kind of in depth. I mean, I don't know what all is in this chip. It would take me way too long. It's simple, but yet when you start getting into Cobb's, there's no telling what circuitry is in there. It's probably just like a flip-flop type deal that is driving the array of transistors. It's only got two, but it would drive these transistors and output, switching the outputs of the bulbs on and off, or gradually up and down, ramping up and down, things like that. So yeah, it's safe to say that we can we can just pretty much, these unplug. Do these unplug? Oh, look at that. They unplug out of the deal. They just unplug straight off the board with these little sockets. I thought they were soldered in. I was about to cut this. In fact, I did nick it right there. And so in theory, I could just hook these direct and these lights should come on, but that would be extremely dangerous. So here's the board. It's had the elf touch. I've made it go bang accidentally. I wasn't even trying. Anyway, yeah, that's basically how these lights used to work. Microprocessor driving an array of transistors to ramp the voltages up and down in sequence. You know, 2, 3, 4, or sometimes even more. I've seen commercial strings that have like MOSFETs and things handle the big C4 type or C7 type bulbs, the big stuff. A lot of higher currents and stuff. You know, the box, interesting box. It appears to be waterproof. Of course, it was for indoor and outdoor use. Properly built. Separation is something yet to be desired here, but it did get the job done. So yeah, that's it. That's all I can say about it. Sorry I blew it up, but it was on its way to the garbage, the recycle anyway.